So this is a nice addition to what we just discussed in the previous podcast on how EV numbers can actually reduce your utility bill. People always worry that people with EVs will use electricity and the cost will go up, but that's not the case, it turns out. And again, we look at another study in California. The California effect we talked about before is important because it's a rich state, tends to be very progressive on environmental issues and actions and regulations and so on. And the other states tend to watch California and adopt some of the practices that may work for them as well. So this study basically looks at the impact of having EV charging stations nearby and whether that affects the housing prices negatively or positively. Without going into too much details, I'll just give a brief introduction, and that's the introduction, and that's always better with just reading the abstract so you can follow up if you are interested in more details. Vehicle electrification is critical to enabling countries to develop more sustainably. Wider electric vehicle adoption relies on the deployment of EV charging stations, which is obvious. However, the local benefits associated with offering more charging opportunities to nearby residents remains unexplored. Here we provide empirical evidence on the impacts of proximate EVCs on the housing prices in California, so electric vehicle chargers. We apply a hedonic property value approach using the EVCs data combined with about 14 million housing transactions records during 1993 to 2021. This hedonic approach is basically where you look at prices and consider multiple factors that affect its market value. So in this case, for example, whether the housing prices were affected by EVCs in addition to other environmental factors, proximity to parks, schools, etc., are considered typically in hedonic approaches for housing. Our results show that access to charging infrastructure can be capitalized into property values. The average price premium for houses with EVCs within 1 kilometer is about 3.3%, which amounts to US $17,212 based on the average prices in California. This is compared with homes without proximate EVCs. The largest effect is a 5.8% increase for houses with EVCs within 0.4 to 0.5 kilometer compared with houses without proximate EVCs. So there is an optimum distance that is somehow preferred, maybe. We find different results across neighborhoods with diverse socio-demographic characteristics. Proximity to EVCs increases traffic flows by 0.3 to 0.5% and lowers particulate matter emissions by 1.3 to 2.2%. The increased property value after EVC installation can incentivize the private real estate sector to expand the availability of charging services. More information on the housing price premium should be provided to facilitate the deployment of this sustainable infrastructure. So the attention paid to proximity of EVCs obviously is important for people who own EVs, and people who own EVs may be relying on the income level, the commute distance, range anxiety, and various other factors. Here is how the numbers of charging stations have increased over time from 2019 to 2021. Before that, 2015 to 2018, 2010 to 2014, 2003 to 2009, and 1995 to 2002. So you can see the various color codes there. California remains very progressive, and very rich people also keep buying lots of Teslas, which are expensive, even though now there is a cheaper model. Impacts of vicinity to EVCs on housing prices. So impacts with individual year and month of year fixed effect. So various ways of doing it. This is without county times year fixed effects. I think this misspelling here, country instead of county. So housing prices, distance bin in kilometers. So you can see that maybe when it gets very close to home, the proximity to increase traffic probably spooks the house buyers and drops the prices, but there is an optimum at around zero point 0.4 to 0.5 kilometers, and as the distance increases there is a small premium, but it drops compared to this optimum distance. This is change in housing prices with EVCs when county and year fixed effects are considered. Numbers change a little bit, but not so much. The message remains the same, that if it's too close, then the pricing may drop, house prices may drop, but at 0.4 to 0.6 kilometers or so is the peak increase in values. So there is the income per capita, which obviously affects the housing price. So this often is related to other factors like how good are the schools, how clean is the environment, proximity to maybe the beach, the mountain, ski slopes, and so on and so forth. Housing price also drops based on EV sales share in percentage. So as this has to be understood, the percentage EV sales drops off as housing price impact drops off, so that may be related to who buys, and that's obvious here. Annual income growth and housing price, so you can see that income growth is higher, the housing price effect is higher, and so on. I won't go into the details. Environmental awareness may have some impact. Okay, annual house price inflation and white share, so race may matter as well. Finally, change in housing prices with EV charging stations with county times year fixed effects and business patterns. So some other factors are considered here. So we are again looking at distance, but here impacts of proximity to EV chargers on housing prices, adding business pattern as a control variable. The dependent variable is the log of housing prices here. Centers of the error bars are the values of the coefficients which represent point estimates from the regressions and indicate the average effects of EV charging stations. Their 95% confidence intervals are plotted vertically here. Total number of observations is 8.7 million. Number of houses with proximate EV charging stations within 1 kilometer is 1.10 million. California is a supremely expensive place for housing, and that without EV charging stations is 1.86 million. So this corresponds to something to do with the business patterns. Standard errors are clustered and so on. So in other words, there are confounding variables that have to be considered, but you can still see that the premium increase in values is around 0.4 to 0.6 and then drops off. But here proximity to the EV charging station is not negative here. It's actually one of the highest numbers when you include other variables like business patterns. So you can look up the details there. I just wanted to include this here so that you are aware that as we keep going boldly forward on electrifying everything and increasing fraction of electric vehicles, electric charging stations network has to grow, and obviously one has to worry about how that may affect housing prices, because there is evidence that putting up windmills in backyards and the noise associated with them tends to lower housing prices in some neighborhoods, and many neighborhood associations don't even allow to put up windmills because they think aesthetically that's not very pleasing, in addition to concerns about bird kills, noise, etc. Okay, so I'm going to leave it here, but it's a good article. You can look up the details and see if such studies are also being done elsewhere. Okay.